So let's take some time here to talk about something that I found pretty cool. So Jamf recently released this blog post, and what's most interesting about this blog post is we have an update to Odyssey. So this is an Infostealer. It's been around for a bit, very similar to Amos or Atomic Sealer for anyone that's seen that before. Um, and what I found most interesting about this, besides it being signed and notarized, which does not happen a lot with these types of info stealers, is that the dropper is written in SwiftUI. So I wanted to just spend some time talking about reversing a SwiftUI app because it's a lot of fun. And yeah, so let's just dive in. So this was released a couple days ago by Jamf. So we'll use information in here to kind of walk through the analysis. So let's go into Binary Ninja. And this is a SwiftUI app. Usually, one way that you can tell this all the way at the beginning of your analysis, if you go into the triage summary view here for Binary Ninja, and you look at the imported libraries, you'll see a reference to SwiftUI up here. So SwiftUI, it's going to have Objective-C in here. We can see reference here to the Objective-C like runtime, dilib. So let's dive in. So let's start at the start function. Now, if you look at the symbols for Swift before running a specific plugin, it's going to be a little bit difficult to see what these functions are. So these are mangled. These symbols are mangled. So there's a plugin that you can use to demangle it. So in here, plugin Swift Demangler. This will just take a moment, and then we can start our analysis. So now we can actually see some calls that make sense to us and symbols that make sense. And if we go to the start function, let's go in here and then come back to start so it resolves. We'll see that all the start function does is call the app.main. So this is a GUI application. So yeah, we're not going to see the actual start since, you know, GUIs are a little bit different in command line tools. So we need to go and see where we're going to start the analysis of this GUI application. Usually when it comes to Swift, and especially if I know that it's a malicious application, I look for calls to certain Objective-C objects that are known to be used maliciously. So one of those, if we can look and find one, let's go down. We can see references to Objective-C message send, which is how message passing happens for Objective-C, and we can see a bunch of these are called here. Having looked at a bunch of samples like this, I can already see a couple methods here, set executable URL and set arguments. That is for the NS task object. So let's go find a reference to that object. So we're going to keep going down the symbols, and we should find a reference to NS task right here. Okay, so let's double click on this and look at the address for NS task here, and we see a data reference to this class, and this is going to bring us to the Objective-C class ref section of the binary. And if we highlight over this address, click on it, we'll see which function or which subroutine has a reference to this NS task class. So we're going to start our analysis here. I can just rename this for fun to see where I'm at. Task setup. Okay, so let's begin from here. And we're going to skip over a bunch of stuff up here. Swift from a decompiled state is pretty verbose. So let's begin at where we see the NS task get initialized. So we have the structure for this Objective-C object, which is going to be the return value of the Objective-C message send call, which is how message passing happens in Objective-C. And we're seeing this reference to the NS task class, and we are passing the method, the init method. So this is going to initialize an NS task. So all that to say, we change this to NS task. Okay, so the next call we have is for this URL.init. Now this is Swift, not Objective-C. So in Swift apps, you'll often see this where there's like bridging between the two. We have this, which if you reverse, malware often, you can see that this is ASCII. So let's just resolve that. Right, so character const, and that is /bin zsh. So that's like the default shell for macOS. And we'll also see this value being passed alongside. So there's two arguments here being passed to this URL init method. Okay, so this is going to initialize a URL, and this is going to get this argument for the file URL with path. Now, this is a Swift string. This is a small Swift string because it's less than 16 bytes. I believe, yeah, if I remember correctly, 15, including 15 and bytes in length and down, we have a small Swift string. And Swift strings are struct, so there's two members of the struct. There's going to be, if it's a small Swift string, it's going to be inline, which we just saw. And then the next member of this struct is going to be the size. And you can tell that this is also a small Swift string because it begins with a 0xe, which is common when you're looking at these types of strings. And then the size is going to be the value right after that e. So this is going to be 8 bytes in length. And this struct is being passed into this URL init, which is going to initialize this URL, which in this case is not a URL like a network URL. This is like a file URL, so like a path. So that's an object that's going to get initialized. So this will be the bin zsh URL object. After that, it's a little bit hard to see because of the way that Swift works. But when we use self, we'll have a reference to self, and essentially what happens with that is when we pass self or we pass a method to self, it shows up kind of weird in the decompilation. So we're getting this URL that we initialize, and we're passing this method for bridge to Objective-C. And what that is doing, it's in converting this Swift object into an Objective-C object. So this is we're going to change this variable to bin zsh. Okay, and now we have this Objective-C message send. We're using this NS task class object, and we're passing in the set executable URL with this argument. So that is going to set up our executable URL for this NS task. Okay, so continuing, and here's where we have to go into the disassembly, which is prettier anyways. We have this Swift alloc object. So you'll often see this when you're looking at Swift applications, and essentially this is like just an array is what I would call this. So let's just call this our arg array, since I've seen these before, and we're setting up this array to be passed in as the arguments for this NS task. What is a little bit strange sometimes is you'll see this huge mem copy of these bytes being passed into this array plus 0x10. Okay, so let's look at the disassembly to understand this a little bit more, to figure out why that is. So we're going to go over, we're going to look at the return value of the Swift alloc object here. So we have the Swift alloc object. So this is going to be our array in x0. So x0 equals array. Now we are going to load. So we're getting, using a page, we're getting a pointer to this address, and then we're going to offset plus 0x830 to get an offset to this, and this is then loaded into a queued register. So this is 128 bits, 128 bits loaded into Q0 register. If we look at this, if you've seen Swift applications before, these are members of a Swift array that are getting set up, and we have the arg count in this sense, and we have capacity. So this is saying that this array is going to have two members of this array, and we have there are two elements in this array, and we have the capacity, which is always going to be times 2 of the count here. So let's go back. That is moved into x0, and that's 128 bits. And those 128 bits are then stored at the address of the array plus 0x10. So just put 16, 16 over, and that's going to be the first two parts of this array. So that, if looking at this, you can also see that this is going to also write to x0 plus 0x20, since that's going to be 128 bits in length. The next thing we see, so this sets up the top, we'll say top like this because we're still missing the metadata that's actually at the start of the array, because this is an offset plus 0x10. Sets up the top of the array. Now we're having this move instruction. So we're moving bytes into W8, so that's the 32-bit equivalent of the X8 register. And this is a small Swift string. We can see the 0xe, which is indicative of being a Swift string. So this is 2 bytes. We can see the value of 2 there. So we can resolve this -c. So if you've looked at like the execution of bash or shell or ZSH is usually passed alongside with a -c in this case. So we are moving these 2 values, right? So the first part of this Swift string is moved into register W8, and then the size is moved into X9, and both of these are stored at this address. So we set up that whole part of the array, and now we're doing this offset plus 0x20, and we're putting in these values onto this array. Okay, so this right here, we're not going to worry too much about these instructions. This is to like grow string guts, which we're not going to get into. And we're going to continue from here. So now we have those 2 parts of this array at the top, and we're going to see these move instructions and these move k. So move is going to move these bytes into the X8 register. And if you look down, the way that Binary Ninja shows this is pretty cool. You'll see those 2 bytes right here at the end of this huge chunk of bytes that were moved into X8. The move k instructions is a move and keep. So you keep whatever values were there in the register already, and you just keep moving 2 bytes over by using this this move k and then getting the offsets here of where you put those values into that register. So it becomes this huge and it contains all these bytes inside of this register. So if we look at that, we'll see that this resolves into the chmod plus x string. And if we go back to the article, we'll see that so it retrieves an additional AppleScript payload using native Swift APIs. And once downloaded, the app shells out to chmod to make the script executable, and then uses sh to execute it. Okay, so this is that chmod that is referenced in this article. So it's going to spawn a shell, and the way that it would happen is through the use of an NS task. So zsh-c chmod plus x, and it's going to then have the return value of what's downloaded by this sample, which is pretty cool. All right, so let's continue. Chmod plus x is here, and we can see chmod plus x is then added into the arg array down here. If we focus on the decompilation, and it's added as this object 6 here. If I change this, it's going to make changes to everything. So let me just do that. Yeah, so it's going to resolve this, and you can use the hotkey R in order to resolve these. So let's look at this, and the string append, what value is this here? This is a backslash. Okay. So now we have this URL.path.getter that is being passed in from the value of from the register x22. Now I don't remember seeing x22, so we got to go up and see where this comes from. Okay, so this actually comes from the argument that was passed into this function, which it looks like it's not aware that there was an argument passed here, since the function definition doesn't indicate that. So this argument, arg1 path to x22. So we can make a change here. Not sure how this will appear, but we can just set up a arg1 here as an argument that's passed into this function. Not sure where we'll see it used, but we can just continue from there. Okay, so going down, so we know that whatever was passed into this function at some point ends up being used down here within this this function which is pretty interesting, right? So this URL path getter, which will then return into x0, and then it's used as an append for the chmod plus x argument. So it's going to append that to that string, right? So that's going to modify this chmod string to have that string appended to it. And when it gets added down here, let me make sure. Yeah. So let's look at that really quickly. How do we know that the url.path.getter is used here? And how do we know that the string.append is applied to the chmod string? So that's where self comes in Swift, which is an interesting concept, but it doesn't really show up here in the decompilation. And self is used within the register x20. So we have this, the address right here for the chmod plus x that we talked about before. That arg, that string, is passed into x20, and then we have a dot append happening. So essentially, so self is equal to x20, and what's happening here is x20, we're passing the append function here. Okay, so that's what that would look like, where the method, append function, and then the arg that's being used to append it is then passed to the chmod. So this is going to set up that chmod, and we can see this arg array is later going to be bridged to this Objective-C NS array. So we can change this to be an NS array. NS array, let me just say args for fun there. And then we're going to use that same NS task that we talked about before, and we're going to pass this args array as the set arguments, as the argument to the set argument method, and pass that to NS task. Okay, so then we have reference to an NS pipe, which is common when it comes to like an NS task, and we can see set standard out and standard error are passed these NS pipe. And then we have the launch and return error, which is going to then get the NS task and execute it. So execute chmod. Okay, so let's continue here. Let's see what else happens here. So we know that there's going to be something passed to this. So it said in the article that it grabs this from some domain and then it executes it, or changes the permissions and it executes it. So let's just see what happens here. Yeah, we see references here to this NS pipe and reading the result. There's a lot of stuff here for different strings. So let's talk about these strings before we go back. So in Swift, large strings are a little bit different. They're not passed in line, they're passed via a reference. And you can tell that a Swift string is present when you see this 0x8. This is a large Swift string, and it actually requires you to add 0x20 to get the actual offset of where this string is in the binary. So we need to do like a bb.read down here. Make sure I write that right. 0x and then plus 0x20, And then the size is going to be passed alongside here with the 0x24. So I'm just curious what this string is. Error during data installation. And these bytes end up being, it looks like Unicode for some kind of symbol. So let's just grab this. And I'm just going to make this a comment here. Okay, so we know that the chmod happens. We know there's probably another reference to executing this at some point. But I'm curious where this gets downloaded from. So this NS task is handling the setup for this NS task. So let's see what calls this and understand this a little bit better. So if you highlight over, you click at the function we're working on, you can come into code references and then see where this is called. This is called within this subroutine. Let's see if any of this makes sense to us. Yeah, so there's more references here to, this looks like, yeah, this looks like small Swift string, unknown error. So maybe this is for error handling at some point. Yeah, error.localize description getter. We're setting up another array here, and this is probably going to print out, yeah, this will print out an error here using the print function. And you pass an array to this print function, which is why it's setting up an array up here. So this is another large Swift string. If you wanted to take a look at it, we can just get this address. I'm curious what it says. So let's go back to this bb.read, replace this, and then it is size of 0x23, failed to download order data, and some kind of Unicode characters. So put that here, and it looks like another error message. Okay, that's cool. But this happens within this, and this happens as a result of an if statement. And I'm curious what this is called from. So let me just put like results in NS task, question mark, and then come back here. So this subroutine calls this. So let's see where this is called from. Oh, so let's go back. This, and this is called in two places, it looks like, within the same function. So let's take a look at that. Okay, now this makes sense. So this is part of a stack block here, and this block is then going to be passed into this completion handler. So this is going to be set up and executed upon successful completion of this session, this NS URL session. So let's go up and just kind of make sense of this a little bit. So this is going to be our network session. So there's a lot of stuff that happens here. We're not going to focus on that. That's a lot of metadata stuff, and it looks like it's also setting up this block. But we're going to focus on this URL.init, which is passing in a string. And we talked about this already before. This is going to resolve into a large Swift string. So display as, and let's take a look at this. And bb.read, did that wrong, 0x, and then plus 0x20. I've talked about why you have to do this in presentations and in videos before, if you're curious. There's 1b. So that's the size of this. And this, I believe this is the C2. Yeah, right here. So it silently reaches out to a remote server, retrieving an additional AppleScript payload. And the way that it does that is, we can see that here. It sets up this C2. C2 is set up in it. And then this is going to then be bridged. The next time we see a reference to a URL, it's all the way down here. And this URL is going to be bridged here, and then this is going to be the return of that object. So this should be the C2. And let's change this really quickly. So this is an NS URL session. And then we're passing in this block. This is all the stuff for the block. And we have the block that's passed in. So here goes. This NS URL session is going to be passed a download task with URL. The URL is the first argument that would appear after this colon here, and that is the first argument that's passed in C2. And the completion handler will then be this block. And the block, although it's kind of hard to read here, this block has this function that we talked about, which results in this NS task. So let me do this. Handle NS task, or no, handle download. Now that when we go back in this network session, we'll see that this is related to this this block that was passed in as a completion handler, and then that ends up reaching out and downloading this file, which then uses chmod's exit to change its permissions in order to allow it to be executable, and then executes it. All right, so we kind of rushed through that a little bit at the end there, but just wanted to show where this came from. First place, it's pretty interesting that it leverages this dropper via SwiftUI app, and I think there's a quick video showing this. Yeah, it's pretty interesting. We can look for all these strings if we wanted to within the UI app. This will all show up within the decompilation, but yeah, pretty interesting, and just what gave us an opportunity to talk about some cool Swift stuff. All right, that's it for today.